Hello, welcome back. So today we are going to know about how the communication happen in a system design application. So if you are designing any application, you have to communicate between different components or between different application. Suppose you have a e-commerce website, okay? So you have to communicate with. Suppose a person come to search or buy any product. So you have to communicate whether the product is present, what is the price. uh, you have to communicate with the bank whether the payment happen. So there are lots of communication happen in any application. So how this communication happen, what are the different types of communication, how this communication, where to use this type of communication, we will discuss each and everything in today's video. So basically there are two different types of communication. First one is synchronous communication. Second one is asynchronous communication. Okay, so let us discuss with a synchronous communication. Suppose you have application 1. Okay, you want to request any detail from application 2. Okay, so the application 1 will wait till the response will not come. Okay, till the response will not come, application 1 will wait. This type of communication is called synchronous communication. So can you give any example? Let us discuss. Suppose you are going for bank to withdraw some money. Okay, so you may fill some form. Okay, submit it to the cashier. Okay, cashier. So cashier will take the money, take your form, and you will wait till the cashier does not give you the money. You will not move it anywhere. So this is called synchronization communication here. Another example, suppose you wanted to eat something, you go to any food truck. Okay, you will make a payment for a cheese pizza. Okay, cheese pizza, and when you do a payment, you will get a token. From that token you can purchase the pizza. So when you make a payment, then before you taking the token, you will not going to move, because when you are going for second step, that is asking the for pizza, then that person may ask you to produce the token. So your second step you can't go for second step without getting the token. So here when you make the payment and till you do not get your token, you will waiting for token, because you know that without token you can't do your second step. This type of communication is known as synchronization communication. So you will ask you where this type of communication is happen, why we need this. So why we need this communication? So let us discuss about why we need this type of communication. First is, suppose there is an application, it has to perform certain work, and it can be performed with help of 4 steps. Step 1, 2, 3, 4. Suppose step 1 has to request some data from application 2, and with the help of this response, and this response is used to calculate something, and with this calculation you can perform step 3 and step 4. So now whenever there will be any sequential step where response is required to complete other sequence, you will always use synchronization. Why? Without getting the response you can't do the calculation which is in the second step, and without completing second step you can't go to the third step, you can't go to the fourth step. So here synchronization is very much required. Another use case is transaction. Any type of transaction or any type of booking always require synchronization. Suppose in e-commerce website you want to make the payment, so you click on payment tab. Okay, here you fill your card detail or any bank detail without your validating your card, whether your card is number is correct, or you expiry date or CVV number, any type of number you did it. Without the validating it, you cannot go for payment. And when you enter the payment, you may ask about the OTP or any type of confirmation. When without your entry of OTP, your booking confirmation does not happen. And without your bank again show your booking confirmation to your e-commerce website, your order will not confirm. So here each and every step there will be a require of confirmation to do second step. So this type of thing require a synchronization confirmation, synchronization communication, and the similar way of booking. So if suppose you are doing any type of booking of hotel booking, same type of thing happen. And this type of thing also require for transaction, any type of transaction, any type of booking. Always remember there it always require a synchronization communication. Every bank, whether it is American bank or Indian bank or world's any bank, any type of payment, Visa, MasterCard, everyone use synchronization communication to confirm their payment. Now, how this synchronization communication happen? So let us discuss about it. How this happen? Suppose application 1 doing any process. So you know a process has a multiple thread. So one thread requests the response from application 2. So suppose the thread is T. So till the response does not come, this thread get blocked, and this thread can't do any other work till the response does not come. So sometimes this is called blocking call. Why it is called blocking call? Because this call block a thread, and when the response come from application 2, then this thread get released so that it can perform another work. So I hope you understand. Any application 1 have a thread which requests something from application 2, that thread get blocked and thread only release when it get response. I hope now you understand it. Now you can't use this type of process everywhere, this type of communication everywhere. So you require another type of communication, that is called asynchronization communication. Asynchronization communication. So what is asynchronization communication? Let us deep down about it. Here, suppose application 1 want to request anything, okay. So if application 2 is busy, or application 1 does not require that response immediately, so what will happen? Application 2 give him a tracking ID. So when after some time application 1 come to application 2 with that tracking ID and get the response. So here application 1 do not want the response immediately. That's the main point. So here what will happen? Application 1 have a thread T. That thread requests a response from application 2. Application 2 produce a tracking ID. Now without getting the response, this thread get released. That's why it is sometimes called non-blocking call, because this type of communication does not block the thread. And with this, application 1 after some time with the help of tracking ID go to the application 2, check whether the request get completed or not. If request get completed, it come with a response. So where this type of communication happen? Suppose sometime you go to a small grocery shop, okay, want to purchase anything. So what will happen? You go to that grocery shop with your list of order. You give the grocery shop owner the list. Grocery shop owner make a bill and give it to and said it to, please come after 10 hour or after some hour in evening and take your order. So you get a order receipt. At evening you go to that shop, you produce them their other bill. With the help of other bill, the shop owner give you your grocery list. So what happened here? When you give them the list, what you wanted to purchase from a grocery list, and that grocery owner give you a bill, then after getting the bill, you will not wait your order at the grocery shop. You go to your office or you go to your work, and at the evening after completing your work, you come again to the shop to produce your bill to take the order. Here you will not wait for your order at the shop owner shop. This type of work is called asynchronization communication. So you will think where this type of communication is required. So let us go down to this. Why we need and where we need. Suppose application 1 want to request any response which is not immediately required, and it takes lot of calculation or computation for application to produce the response, So where there will be a lot of calculation, or where there will be a not requirement of immediate requirement of response, then at that place we will do asynchronization communication. Second, suppose you are going for booking hotel room. So what will you do? You select a room, okay, you made a payment, okay, then payment confirmation happen with a bank and your order becomes successful. So these three steps have to be synchronized because you go for hotel booking site confirm that the room is available, then you go for payment. Here payment confirm everything, your detail, your bank, your call detail, everything. When this happen, your payment bank confirm it with your hotel room that you make a booking, your order will come completed. This will happen synchronously, but you miss one big step here. When your order get completed, you will show a notification will show on your website that your order get confirmed. We will send you an email confirmation within some time. So there will be email confirmation or message confirmation. But email and message communication happen after some time, after 2-3 minutes or sometime. So this will be a asynchronization communication. These three require communication in a step-by-step manner, but this does not require it. You can send the confirmation email after some time. So you thinking why we did not send that simultaneously? Let us understand. Suppose application 1 has a thread T and it had to complete the booking request. So here the thread T will be blocked for step 1, step 2, step 3, but it does not get blocked for step 4. So thread T get released earlier. So if the thread gets released earlier, it can do other work. So the performance of the system get increased. When there is a lot of synchronization communication in any application, the performance get decreases. Remember this thing, because there will be a blockage of thread, and if there will be a lot of time a thread will be blocked, its performance get decreases. That's why if any application release the thread can do other work rather than waiting, because the thread here just waiting does not do any work. So thread get released earlier and that thread can perform another work. So these type of system require just like email confirmation, message confirmation, these type of work we can do another time. So that this type of work we can do after some time, just like email confirmation or message confirmation, and this type of work can be happen with the asynchronization communication. So now you request how this asynchronization communication happens. So there are two ways. One way I already told you. Suppose application 1 want to request anything from application 2, okay. Application 2 will give him a tracking ID. With the help of tracking ID, application 2 go, application 1 go to with the help of tracking ID. If the request get complete, application 2 response with him. This is one way. But there is a one other way. That is, suppose application want to request anything from application 2. So rather than going from directly application 2, what will happen? There will be a message queue here. Message queue. Application 1 send the request to this message queue. Application 2 take one by one message from the application message queue and complete that. When application 2 complete the request, application 2 notify that application that your response get complete. Okay. This is the second way. So let us discuss about the message queue. What is message queue? How it works? So by the name suggests, message queue. Message queue is a queue data instruction. Queue data instruction. You know it. First in, first out. The message which go here first will be out first. So here what will happen? There will be application. Application send message to the message queue, and message queue send the request to application to work on this, and then again response to the application. So here the application 1, it called producer because it produced the request. Message queue is called agent or broker. Okay. And this application 2 is called consumer because it consumed the request. For using in application, there are lots of message queue. See, service provider is available in the market. One such example is a Kafka, which is very famous. Another example is a Rabbit message queue, which is also very famous. Many applications use this type of message queue services for their application. So now you ask where we use this type of message queue services. Where we use this type of message queue services. So let us go to the use cases. Suppose you have an application, okay? Application. It has a limit to perform 500 requests per second. Suppose due to some reason a sudden jump is seen on your request. Sometimes a application, because sometimes you see when in the FIFA World Cup, a sudden jump happen in the Twitter, everyone goes for congratulations. A sudden jump happen. Suppose there will be a sudden jump and there will be 800 requests coming per second to this application. What will happen to this application? Either the application performance get decreased or application all thought get fail. So to avoid this thing, what we will do? We will apply a message queue. All the requests come to this message queue. And with this message queue, only 500 requests will go to the application per second. And when this request complete, we will send a response to the requester. So we require message queue at that place where we know a sudden increase can happen. So every application where there will be a possibility of sudden increase of request, then at that place before the request we apply a message queue so that application does not get lots of requests at a sudden time. Another thing, suppose there will be application 1, it will complete transaction related work. So it has to be completed in synchronization manner. Okay. But you know that bank also produce your monthly report. So for monthly report, you need all the transaction detail. Okay. So what will happen? Your application 1 complete all its process of transaction, and it will send it to the message queue. So that application 2 can make your monthly report on the basis of all your transactions. So here there will be one process which get completed, and with the help of that result, with the help of this application one result, any other thing happen, but they are both independent. Here transaction is independent, making the monthly report is independent, but knowing the transaction detail to make the monthly report is required. So the result of transaction detail is required to make your monthly request. So add this type of thing, message queue you require, so that you send all your transaction detail to message queue, and with the help of this message queue, application 2 can make your monthly report. I hope now you understand it. So there are basically two different model of messaging queue. Let us discuss about it. Two model. Okay. First one is peer-to-peer. Peer-to-peer. Example of this is when you send a invitation through email. Suppose application 1 or person 1 wanted to send a email to a particular person, Here there will be a one producer, and there will be a one client. This type of model is called, of message queue is called peer to peer. But there will be other model that is called publisher subscriber model. You know, there will be a newsletter. Many publisher publish their newsletter. So there will be one application and wanted to send this email to a thousands of people. Message queue, through message queue, it wanted to send this email to the thousands of people. So here there will be one producer, but there will be a thousands of clients. This type of message queue, a message queue which give this type of service, that type of message queue is called publisher subscriber model, and a message queue which give a service to a one producer, one client, or one consumer. That type of message queue is known as peer-to-peer message queue. So I hope with this video all the things related to communication will get clear. We will meet in the next video. Till then, goodbye.